So yeah, I'd like to once again thank my sponsors, GitHub, Synac, BLSD Security, Security Innovation, Forward Security, WebSec, Plurilock, NetSpy, and SciCode for making this possible. And our next speakers are John Whiteman and John Andersen. They're going to talk about living threat models are better than dead threat models. I totally agree. John Whiteman is a security researcher for Intel and a part-time adjunct instructor for the University of Portland. I'm also an Intel alumni there, John, myself, and it's good to see you again. He also teaches the UC Berkeley's Extension Cybersecurity Bootcamp. That's it's actually quite awesome. John holds a Master's of Science in Computer Science from Georgia Institute of Technology. He possesses multiple security certifications, including CISSP and CCSP. He has over 20 years of experience in high tech, with over half of it focused on security. That's kind of like mine as well, half on security, half not on building things. You can also hear John host the OWASP PDX Security Podcast online. And John grows wasabi during his off hours. I'd like to get some of that, John, when we meet in Portland eventually. He's driven by passion for exploration and understanding. He's currently analyzing software development methodologies and technologies to identify and proliferate best practices across organizations so as to optimize asset allocation in alignment with disparate organizational strategic principles. He's excited to explore the application of these techniques on human and AI agents. His mission is to help foster an environment which maintains agent freedom, privacy, and security. We also have another fantastic John joining us, John Andersen. He is driven by passion for exploration and understanding. He's currently, I think that part that I read was for John Andersen. So I'm going to stop here and I'm going to pass it over to you, gentlemen, and looking forward to your presentation.
Awesome.
And I'm going to stop sharing.
Can you see my screen?
Absolutely.
Perfect. Yeah. By the way, because there are two Johns, it's like the John squared thing, the intelligent questions, like the hard to answer one, that goes to John Andersen. So we'll know the context of it. But anything like, trivia for TikTok or something, that's on my side. So anything like that. So John gets the hard questions. That's one thing.
Sounds good. Noted.
All right. Well, thank you so much. This is my favorite day, actually, of the year, the favorite time, because in Portland here, we finally got back, and the Rose Festival is back in progress again, and it is a little rainy but cool. It's just a perfect day, and both of us we really appreciate you coming and taking some time and listening to us. We really are excited about this. But yeah, as the title goes, living threat models are better than dead threat models. The opinions expressed here are our own and not necessarily our employer, which we have to say. And about this presentation, we're going to assume that you already know something about threat models. And it's not about any particular threat model methodology. We have the old school STRIDE, PASTA, VAST, TRIKE, and our favorite DREAD. By the way, if anybody wants to collaborate and create a cartoon for this, we're totally into this. It'd be funny. And we're agnostic to threat modeling tools, although we will be presenting a couple of tools in a couple of different contexts, particularly about some of the nice things that they have, but the limitations as well. What we're really trying to do here, our primary focus, is the collection and definition of data for threat modeling use. So John, can you talk just a little bit more if you want, beyond what was said?
Hey, yeah, sorry, mute button. Yeah, so I'm John. I'm at Intel also with John. And right now I'm focus is on inner source. And so, analyzing software development methodologies, proliferating best practices, playing around with those concepts, hopefully feeding best practices to developers, internal and external, and then also exploring that on AI agents, thinking about, how can we get AI to follow our best practices, and living threat models are, a part of that.
Cool. Thank you, John. And it was already said too, not only micro wasabi, and by the way, the word micro, all that means is that I started out with like 5 wasabi plants and I have 1 left that's living. So micro sounds good, but it's actually a result of a failure as a wasabi grower. And also make kombucha, but that's an old person thing. I'm not going to get into why we do that. Now, something about John Squared and what kind of led up to this presentation. Back in 2016, we both worked as security researchers for Intel's Open Source Technology Center. Unfortunately, that's not around anymore. But at that time, our work, we didn't really work together. We were on the same team, but we're doing different activities. Now I left Intel 2016 for a few years, and I went to Oregon Health and Science University. And there I worked on a project called SAS and the Bad Human Project. And this is where I was using machine learning to predict risk across hundreds of web apps at a time where they didn't really have any expensive SaaS tools. And this was risk prediction from, say, source code for web applications. And I presented that information to B-Sides in 2018. John, a year later, did something called Down the Dependency Rabbit Hole. John, do you want to describe a little bit about that work that you did?
Yeah, with that project, what we did was we looked at open source dependencies. So if you're familiar with like the OpenSSF identifying security threats or metrics working groups, a similar sort of concept, analyzing open source projects, trying to understand whether, there's something secure and robust enough from a general health and their predictive life cycle health standpoint, rather than just, do they have CVEs or something like that.
And one of the things we discovered, so I went back to Intel and we started meeting because we felt like the work wasn't really done. We felt like we had some answers, but not all. And sooner than later, we found fundamentally we were trying to solve the same set of problems. Number one was to find ways to dynamically assess risks associated with these projects. Two, collect a bunch of data from various Git repos and other sources. Three, we need, and this is a big bulk of what we're going to be talking about today, and that is define an open source threat modeling language. 4, integrate these systems into CI/CD frameworks. 5, promote and socialize our efforts for adoption. That's why we're here today. Hopefully get people on board. And then finally, if we solve all these things, we made the world a much more secure place, we would go in and retire. And when I first created the slide, I showed it to John, and John just kind of said, there's a lot of words on this slide. What we can do, let's just go straight to 6 and retire. So we're done with our presentation. Thank you all. Have a good day. Anyway, enough of that. So when apps evolve, so does the risk, and so should the threat model. At least that's what you would think. Typical threat model workflows are like this. The project team will create an architecture design. They'll go then and do some threat modeling, and usually it's a manual process, and manual's good. We think manual processes are good. And this would be the bulk of the threat model early on in the project. Then they'll go off and save that threat model to storage somewhere. And usually at the same time, they're committing code, they're doing manual code reviews if they're doing good secure quality assurance, also static code scanning, SAS tools, dynamic testing like DAS, fuzzing. If you're not fuzzing, you should be ashamed of yourself. Everybody should be fuzzing. And then through this whole process, they're finding and fixing vulnerabilities. It's evolutionary, things get checked in. There's a release every now and then, and yeah, maybe an escape too. You might get a CVE back, but if your project is right, it's transparency, you're finding and fixing and getting patches back to your customers, the end users, as soon as possible. Now, one of the problems with this flow is we call this Hadrian's Wall, but we couldn't find a good image for Hadrian to go this high up. But what's happening is on the left-hand side of this is your threat model is not really evolving as it is on the right-hand side. And so what we call this is the Tombstone Threat Model Process, or TTMP. Now, it's a bit of a hyperbole to say that a threat model is dead if you don't use it or update it after a while, or your threat model expires. In fact, your threat model is probably going to be pretty much intact as long as it doesn't fundamentally change the environment and all that. So we like to use best used before, or best before. And a great analogy would be something like this. It's late at night, it's Saturday, your refrigerator is empty, your cupboards are bare, but then you're under the sink and you see behind the Drano this package of top ramen, and you're looking at it and it's saying, hey, best before was like 2 years ago, and you got to make that critical decision. And that decision is, are you going to eat it or not? And with top ramen, it's probably it's going to live longer than the universe. We know that. But with milk, I don't even think they use best before. I think they use an expiration. So if anything, when you walk away from this presentation today and somebody asks you that John Squared meeting or presentation, what did you learn from there? What we've learned is that threat models are ramen and not milk. And I think we should, John, I think we should create swag for this. I just thought of that. Okay, all threat models should be machine readable. Absolutely, that's things that we found right off the bat. So what we normally see for typical threat model storage is you got your threat model, Teams might be doing it in something like PowerPoint or Word. They may be doing their diagramming in Visio or something like that, and they save it off to something. Now, these can be pretty big files. Sometimes teams would then do, convert it or export it to PDF, and those are much smaller in most cases, but they're read-only and they're not really parsable. I've seen teams go and do threat modeling and take a picture, say, of a whiteboard, and they use that diagramming they had on the whiteboard as their threat model. Nothing wrong with that. Or they've actually used a tool like Paint, Microsoft Paint or GIMP. Hopefully they didn't save it as a BMP, but that's also part of what they're using for a diagramming piece. Other teams now I see more often are doing something like Draw.io or some related ones. And what happens is when all of these applications save, like you save that application to data, we call this application-specific languages, or ASL. We'll use the Draw.io as an example. Now, most people, if you've used it before, are aware that there's an online version, but if you didn't know, there's also a Visual Studio Code version. It's a plugin. And what's really cool about this is if you're already in Visual Studio, you're probably in the same place where you're doing your coding and everything else. You're under your repo directories. And so when you install this plugin, it comes, if you see on the left-hand side here, they call them stencils or templates, whatever, but you got these pre-made objects. And out of the box, Draw.io comes with threat modeling. And you see here, all these nice little things that you can easily drag over to your canvas, and you can quickly start to diagram. Now, this threat model that I have here is going to be the one that we're going to be using throughout the rest of this presentation. But it's very simple. We have three major components. We have a client application, could be a browser. It's out of scope, and it's communicating to web server. That's in scope for us. It's talking across the network. It's doing the right thing. It's using HTTPS, TLS for encryption and authenticity. And then on the other side, we have a customer database. And again, we're talking to it across the network. This could be behind a DMZ, it could be off in the cloud somewhere, but we're trying to do our best. And these lines in blue, these dashed lines in blue, this is going to be our trust boundaries. So we can easily diagram with these ready-made pieces. We have other areas if we wanted to add style and all that. But again, we're really trying to threat model, but use, not spend our time to make it look pretty. Now, if we go and save this, there's various ways. You can export it as an image. You can do all of that, but they also have what they call a .draw.io file. And all that is this machine readable XML. And XML is what we call a general purpose language. We love GPLs. Other examples are JSON, YAML. And if you take a look here, there's a lot of data here, but you can, if you just take a little time, you can tell that there are some areas that are, first of all, this is a very small footprint, but there are areas where you start seeing things like mixed data and the content. And so we don't necessarily care about page width. That's not going to be a vulnerability if page width is greater than 850 pixels, but we do care about these other areas like the database and some other components from there. Threat modeling tools are dangerously shiny objects. This is the biggest mistake I think people make, and we did it too. And this was about, I say, the second year where we started talking about this. We said, hey, that's great with Draw.io and PowerPoint and all of that. Why don't we just build a tool that does everything, not just complementary? So we could have diagramming, could have your APIs, reports, templates, stencils. We even talked about gamification and even something like putting on like a virtual reality headset, grabbing pieces in the air and putting things together, right? But when we realized quickly is that this whole thing starting with the tool, that's so 1990s, and it's always a big mistake. What we found is that most threat model specific tools today, they're not CI/CD friendly. And it's not because they don't have the features to automate, but it's because of a lack of a common open threat model language. And what we mean by that is when you save that ASL data, app 1, app 2, this could be something like Jira, this could be some other tool out there. The teams would have to build some custom tools to talk to these other components to integrate into their CI/CD environment. And that's a tough call, especially if this is just a single purpose language and other people don't use it. And I think that's one reason why we're seeing these challenges. And also it's hard enough to get teams to do security in the first place. One thing we notice out there too, there's not a lot of threat modeling tools. If you look, there might be maybe a dozen or so. There's a bunch of others that have false starts, but there aren't that many. And I grabbed 5 for this table here is to illustrate a few things. We all maybe know Kairos, which is cool because it also includes things like social engineering as threats, where a lot of tools kind of miss that. But Microsoft Threat Modeling Tool, that's gone through a few iterations. Our favorite OWASP Threat Dragon, Threagile, if you haven't heard that, look that up now, and Threat Modeler. And they can come in all types in terms of licensing. Many are open source, which we like for what we're trying to do. Microsoft is free, but it's proprietary, and Threat Modeler is proprietary. I'm not sure if they have a community version, but you're going to pay money for the good stuff. When we talk about data, and we're coming back to the data, there's really 2 major formats that we care about. There's the ASL stuff that we talked about. Again, that's the application specific one. And most of these applications have these export formats too. And if the export formats are not really parsable, like Kairos again, ODF, RTF, doc files are pretty tough to manage when you're parsing. Even the Microsoft tool does have HTML, which is a domain specific language, but maybe not the best. And OWASP says PDF, but DSL formats JSON. The thing I want to talk about Threagile though is for both the ASL format and the export formats, at least it supports a GPL, a general purpose language, YAML on the ASL format, and JSON on one of the export formats. And we'll illustrate why this is so crucial for what we want to do. Here's an example of the Microsoft, the latest tool. They again went through a few versions. The latest version has support around Azure, and it's a great tool. And it's GUI based. You start it up. You have a nice canvas here. You can put your objects in here, similar to what we saw for Draw.io. But the nice thing about this, it includes all of these attributes for the given type of object. And in this case, this is a process. So when you're thinking about threads, a process might be, is it running elevated? It doesn't have input surfaces and things like that. So this is what is really great about this tool. Now, when we go off and save it, again, it's GUI driven, so you have to start it up and do all your things. But when you save it, the ASL part comes with this .tmz file. Commit this to memory, right? This is what I call ponderously parsable. It is XML, but it's got a mix of HTML. I see hieroglyphics in there. I don't know, Sanskrit in there. Everything is in there. If you want to parse and figure that out, go for it. But the actual export file is HTML. And I don't have anything really bad against HTML, but again, these things are a bit dynamic, right? Based on the structures that come with it. So we'll have about the threats, maybe a summary, and down here, it will have that diagram that we created in the canvas, but this is embedded as the binary inside of it. So what happens is, because this is not really CI/CD friendly, what you need to do is you open the app, you have to export that report to HTML, then you got to go and extract this diagram, use something like Beautiful Soup, but there you go. Now, I was going through the MSDN format thinking, well, I must have the old version because I'm sure they did something better here. This is back all the way from 2017, where somebody was saying that, hey, wouldn't it be really cool if we could take this diagram and map it to the actual things back here, like what we're talking about today. Come on, Microsoft, get with the program. And we feel that they kind of dropped the ball here because it's not really, again, CI/CD friendly. By the way, we have our own favorite threat modeling tool. This tool is not in the list or the table that I showed before, but this is John and I's favorite tool. It's the Etch-a-Sketch. And we were talking about if somebody comes in for a job interview and they're a security person and you give them a scenario where they have to do some diagramming here for their threat model, we give them that scenario and we tell them, okay, you got 10 minutes to do it. And we give them an Etch-a-Sketch. And if they run away, we would hire that person. If they stayed and finished it, then we'd be very scared of that person. Anyway, sorry about that. Application specific data, we just talked about, a machine readable, very specialized mixed content, not portable, heavyweight, right? General purpose languages, machine readable, generalized, JSON, XML, YAML. We love it because they're widely known, they're accepted, they're easily recognized. You don't even have to know how to create the parser or use parsers for them. In fact, that's the nice thing about them, is the parsers are already created. You never want to write your own parser, right? Michael Leibowitz of the old days, never. Parsers are hard. Great presentation. What we want to talk about next, though, is domain-specific languages, DSLs. Again, machine readable. Notice this is the common thread. They're specialized and they're idiomatic to the domain. Very compact and lightweight. So some that you already know, HTML, SQL. HTML, you think of web pages. SQL, you think about relational databases, right? And that idiomatic piece that I'm talking about, that's what gives us SQL injection errors, right? There's specific things about it. I want to talk about two other languages. These are diagramming languages, modeling language, Mermaid and PlantUML. And you may have seen these already in action and may not have been aware what they were. So now if we talk about Mermaid, just with a few lines of code, the Mermaid syntax here, if you've never seen this before, if I click on this, it's wonderful. You get this wonderful diagram, all of this information contained with just a few lines of code. We're not talking about an image. We can parse this, but the challenge here is this language, you would have to figure out how to parse it. It's very specialized. Let's take a look at another, the competitor, PlantUML. UML, by the way, is a modeling language. It's domain specific, but it's based on UML. And the same thing with just a few lines of code, we can come in here and define an equivalent threat model with this, at least with the diagrams. Now, obviously, we'd have to put more information in here, but we like the fact that, oh, now we have some syntax, now we have some structure, but it's not quite what we want yet. But at least we have something here that we don't necessarily need a full-blown tool to do things with. So what is our goal? Why am I talking about languages up to this point anyway? Well, as I mentioned in the beginning, we want to define a threat model language, a threat modeling language, an open language. And open means we want to do it as an open architecture with heavy community involvement. Now, when I first, this is yet another slide, I was working with John, I'm like old school. I mean, my threat models go back, pre-Civil War days, and I'm thinking like, we got to get the standards team in, we got to get the ISO people in, we got to get the IEEE people in. And John was really quiet. He didn't really say anything. And then he came, John, tell me why this is a better way of an open architecture versus the way I was describing.
Yeah, and John and I, we played around with this standard architecture, and came to, standards are hard. Standards require that everybody agree on the whole standard, right? So instead, what we're suggesting is, okay, let's agree on a few things, and then we can all have, sort of interoperable architectures as within this realm of the open architecture, and eventually, maybe ideally we converge on some standard, right? But we can't. Let's not start there, let's not start climbing up the standard mountain without fleshing this out as a community first, right? So the goal is to say, hey, here's a couple pieces of metadata, right? Which we think the open architecture should include. If you decide that you want to do something slightly differently, that's fine. We're all still going to be able to interoperate as long as we include these several pieces of metadata.
Yeah, perfect. And we didn't want to pay, if you want to download the standards, you have to pay for it. The people that are really doing the work is what we want the people here. Again, we're thinking of a CI/CD supported system. That's where we're looking at with the troops on the ground. So what this diagram represents here is this gray area is that standard. Consider that the paper that has the grammars, all of the dependencies, the academic paper, if you will. And then what we want to do is create this domain specific threat modeling language from that, and we want to use it and represent it as a GPL, do it in GPL. So again, it would be something like JSON, XML, or YAML. We want to avoid that specialized syntax like we saw for Mermaid and PlantUML, because that's just going to be a big turnoff. If we can represent this as a GPL language, and we're going to show you an example in a second, how important that is as a first impression of anything for adoption from there. We believe that once this is defined, they will build it. So do you remember when we talked about building those tools first and doing all these wonderful things? Again, that's so 1990s. If we have this language already defined, then people will say, oh, I'm going to invest my time. I'm going to go ahead and build a threat modeling tool, but my tool is going to be cooler than the other people, but it's going to be based on that same language that everyone else is using. It's going to be IDE plugins, GitHub rendering. As you know, GitHub does Mermaid and PlantUML and code syntax and all of that, or even editors for it. So Threagile is one of our examples. I just learned about this about a month ago. A coworker of mine, Rich Hogan, was talking about this, and also these domain-specific languages, and why I got really interested in them. So some credit to him. The idea is that if you take a look here, this is a threat model. It's represented as a YAML file that Threagile understands. Now, if you don't understand anything about maybe the structures, but you know something about threat modeling, you can look in here and you can say, oh, well, I know threat models have security requirements. I know a threat model should have something about assets, maybe some metadata on here. This is the oldest threat model, the Battle of Hastings in 1066, and there was some overlaps or overlooks by Harold. And anyway, you know what happened after that. So in addition, if you look at a full file, there's assets, there's flows, there's trust boundaries, and there's customizable things. That's key too. And you have these tags where you can build things that might make sense to your business and nobody else, right? Stores nicely as in the repos as a text file, and it's CI/CD friendly. It's a Threagile, that's the command tool's name. It's written in Golang. It would ingest this YAML file, generates these wonderful reports off the fly, and you can do audits. And we're going to talk about why audits are important and why we need to be doing this. So Threagile is a great one. Highly recommend you take a look at it for the open source. By the way, we have a GitHub repo. We'll send you all the link and all of that for it, where all the slides, but all this stuff that we're working on, some of these demos, that information's in there as well. Now, scan threat models like you scan code. Well, if we have this wonderful threat modeling language, this open architect language, we can do some of the following, which we really can't do right now. Number one, we can do things with the threat model file itself. We can write a linter for it. We can look in the file and we can do things like, oh, it's missing assets. Why does your threat model have no assets? Or some labels are missing. Maybe we see things like duplicate names. Or we can even look for the age of the threat model and that best use before date. We can do that as well. And these are quality checks that we call it. But we can also do scans against that same threat model file for vulnerability checks, like a SAS scanner. In this case, we might be looking for a lack of or incorrect mitigations. Maybe you have a network connection. It says HTTP, but you're not using TLS. That is a vulnerability, or you have nothing on there at all. The other thing, which we'll talk about later, and this is the core, what I believe is for this whole presentation, is with this threat model, you can now start to model or monitor for these check-ins. If you remember that evolutionary thing that I was talking about between the existing threat model and the source code. So for example, as people are checking things in, all of a sudden your source code starts containing network libraries or crypto or something of that nature. But your existing threat model says nothing about networks, says nothing about cryptos. That can raise an alert and say, hey, you might want to go back and take a look at your threat model. It looks like we're getting some stuff in here that you haven't considered before. Could be a false positive, could be real, who knows? Now, because we don't have that language yet, we can use something existing, and we want to use our beloved OWASP Snapdragon to make a point. And again, this is open source threat model too. Hopefully here in OWASP, we know about it. Goodwood, Gadsden, Redding, and all those folks. Gadsden is one of our own from the Pacific Northwest. I believe he's still up in Vancouver, Washington State. So it's great to have that identity as well. There's two flavors of ThreatDragon. One is a standalone tool and the other one is a web app. The web app is pretty cool because what you can do is configure it to point to your repo, and it'll automatically do the commits into it. And so all of this threat modeling is integrated into your repo. And of course, that's what we've been talking about. Really nice. Now, as we saw in that table before, there's really two flavors. The ASL is exporting as JSON, and then the actual exports themselves are PDF. In this case, we're going to reverse it. Normally, we want to look at what the exports are. But the ThreatDragon's ASL, the JSON representation is actually pretty nice and easy to parse. So this is the same threat model that I was showing. And if we saved it off in ThreatDragon, this is the actual ASL data that we get. And just at a glance, it's pretty easy to figure out where stuff is. Again, we get this mix of presentation data and some other trackers, but as you would go down, and we have this up there, you can see that where, the client app and all the data and some of the metadata that's associated with it, we would just want to go off and to parse some of this stuff out to create some things. And that's what we're going to do. For this demo, I created three threat models with ThreatDragon. And they're all based, starting with the same thing here with our web server. The first one is good, and I saved it as good.json. Now, when you're in ThreatDragon, when you click on any of these components, you would get this little box that comes up and it'll ask you some questions like, give it a label. Is it encrypted? Is it over a public network? And so that's about what we get, and maybe that's good enough. So we label it. Yeah, it's over a public network, but we're doing the right thing. We're encrypting it accordingly, and that's good. We click on the backend network connection, again, same thing. But in this case, it's not over a public network, but we're doing the right thing again. We're labeling, that's a quality thing, and encrypting, that's a mitigation against such a vulnerability. And then finally, the customer database stores credentials, okay? Is it encrypted? Yeah, at least this is what we're trying to do. Of course, there's many other things that we can do, but for the sake of this demo, these are the 3 things that we think have a complete threat model for this example. So this is a good threat model. Now, a bad threat model is where there are some problems. It could be a vulnerability problem. It could be a quality problem. Now, John and I got really excited about this because this was like about a year and a half ago, I think. Maybe it's longer now, I don't know. And everything's like melting together. But do you remember like the intentionally vulnerable web application or the intentionally vulnerable C program that you use for AFL fuzzing and all of that? We got real excited for training because we want people to learn how to threat model. We could create a project that has intentionally vulnerable threat models, and we can teach students to say, what's wrong with this threat model? And we can do it in such a way that, well, we'll show you how you can recognize that and grade it if you want. So in this case, again, I'm looking at these 3 attributes. I'm calling this protocol now HTTP. I'm taking the TLS out. It's not encrypted. It's over a public network. Very bad idea. In the backend side, we are encrypting in. We left that, but we left out the label. So the label is more of a quality issue, even though this is not a real vulnerability. And in the back end, yeah, we're still storing credentials, but we're not encrypting. So we essentially have 2 vulnerabilities with the encryption part, the TLS, and then the non-encrypted database. And then we have 1 quality issue for the protocol. And we call this bad.json. Now, there has to be an ugly. And I said, well, I'm kind of stuck. What is an ugly threat model? What the heck is that? And I wish we're all in person, because then I would ask you to raise your hands and stuff. What is an ugly threat model? In short, it's no threat model. Shame on you. Your grandkids will come to you. They're going to ask you, Grandma, Grandpa, why, what are you proud of? What are you, ashamed of? In case you tell them I'm proud of you the most, and what are you ashamed of the most? You said, because I never threat modeled, and they just never look at you the same way. So this is what we call it. And this ugly.json is an empty file. All right. Now, what I did, because you saw how that syntax was very simple, application specific language, I wrote a little parser. And if you take all of these things out, all I'm doing is just extracting the info I want, ignoring the presentation data. You can write this in maybe a few dozen lines of code now. In fact, I wrote this probably in about 30 minutes. That's how easy it was. And that's the beauty of having a JSON structure. You understand JSON, you understand the structures, it doesn't take very long. I then created another one called Auditor, which uses parser, consumes that ThreatDragon file, and then it goes and looks for some specific issues. Again, the 3 that we mentioned here would be a labeling issue, or it's the HTTP, not HTTPS and stuff. You would probably do these rules in some text-based file and then consume it accordingly. But just for the sake of this presentation, you can see the power here with just a few lines of code on each side, where now we can parse this threat model and we can start doing things like auditing the threat model. So let me show you the screen here. And what's happening here is I'm going through all three cases. The first one, the good, is that empty, or that good file. So here's good. We get nothing back, which means it's good. The exit status bad. The bad one, we get their 3 issues. And then the ugly, it just crashes my program. It was like perfect for that anyway. So that's what we do. And you see this thing is repeating. Now imagine this in your continuous build environment, right? Every time you get this commit, you're going to run these things, and then you're going to set some rules there. And if you are getting something that's a non-zero coming back, then you take whatever appropriate action, or maybe there are known issues and you look at the file. But the sky's the limit, because we're all on some standard defined open language that we can use for this. So this is this example, and the scripts are there if you want to take a look at it. Now we say, put the threat model in the CI/CD workflow. One way you can do it, and there's multiple ways of doing it. Now we can say, instead of that threat model sitting over there as a PowerPoint slide, we now have this defined language, machine readable, lightweight. We can create an individual branch called threat model. Again, this is one approach. And this threat model is keeping track of the versions of the threat model. So like this initial check-in, this is the stuff that we've done manually. That's all the hard work that goes in, and we set it up as we move along. Now, the branch one, we might get some hot fix, and this null operator means that there's really no code inside it that has changed anything. So we don't need to update our threat model, and we can go ahead and merge accordingly. But let's say we get some significant code changes that affect the threat model. Maybe we're adding cloud components and all of that. And with that, we're going to have to update our threat model here. Now, this is the point, like what we're saying is something significant like that would probably require some manual intervention. Or if it's something small, we'll show you in a little bit, we can actually catch that and update accordingly. Another thing that could happen is we could get something like a 0-day vulnerability. We find out about it, but there's no code or anything. We can almost treat the threat modeling branch as private. It's not being merged in. So we are aware of this. And now we're waiting, maybe it's going to be branch 3 or something that will come along. And it's going to say, oh, we got to put an implement. We have to implement this. But before we make it public, we're aware of that. And we're going to update the threat model accordingly. That's one way of doing it. Another way where I think John and I kind of agree that maybe this other way is, again, we're going to do that initial check-in where the threat model is done manually, but then the threat model itself is really just part of the code. It's part of the regular check-ins at the same branch. So just like the code, you're going to do your SAS scans. You might be scanning for third-party vulnerabilities along with your custom code. And you're also going to be scanning your threat model because now you have those scanners for those. And again, the caveat here is that you're going to want to check. It might not be fully automated, but at least if you have the tools in place to look for things like these deltas, along with some human interactions, it could be a pull request, for example, that might be just the threat model. Those are the things that are kind of natural anyway when we're doing it like this. This is kind of a typical scenario. Now, THREATS.md is the new README.md. And what do I mean by that? Well, everybody hopefully knows what a README.md is. It's a simple markdown file, but it has a special purpose in GitHub, right? So it resides at the root of the repo directory. You can always find it there. And we understand that's usually the place you start when you want to find out something about the repository. Now, inside it, this README file, we were kind of alluding to this earlier, but the triple backtick stuff, right? And then you put something in there. The markdown parser understands it, doesn't understand what's going on inside it, but it assumes you do, and maybe your parser will understand it. So there's this foundation README parser, and then the special purpose could be domain-specific stuff. In fact, Mermaid's a great example of it. PlantUML as well on GitHub is when you look at the markdown file, you got your triple backtick here. We got a Mermaid label here that indicates whatever the parser is on top of that says, oh, I got to pay attention to this because this is Mermaid. It goes in and renders, of course, something simple like that. And I think that's the coolest thing in the world. And that's so easy to do with the README file because it gives us the best of both worlds. Now, I want to talk about something called overlays, and John and I kind of made this name up, but there's something super powerful about it. And the best way I can explain it is start with something called CITATIONS.cff. Now, CITATIONS.cff is not called an overlay, but it's something that's supported by GitHub. If you create this file, and this is the format, it's a domain-specific format, but if you want people, and I think you should, if you got good, if you don't know about citations, but you have a really good repo out there and you want people to, cite it the right way, create this file. And citations, again, we're talking about academic papers or books that may go out and use your repo as for something, right? You want them to cite it correctly. This is the way to go. And as you would expect, who are the authors, the title, version maybe, ORCID names, you have all of those, the date release, and of course the URL. Now, what happens is, when you save this as citation.cff, it's just like the README file. You do this at the top, you'll immediately notice over on the About on your GitHub side, this thing appears, Cite this repository. And when you click on this, all of a sudden you start getting a couple of different flavors of citations, which is really cool. There's APA, which is great for scientific stuff. You get BitTeX as well. I'd love to see something like IEEE or Chicago style or something. People can go and build this tool and add it accordingly. And when you pick this, you get the format that you're looking for. If it's APA, you get this. BitTeX is great because it's kind of used for a lot of other things as well. And this is all it is. Now, you say, well, what's the big deal about that? Well, if we do it for something like we create this file called THREATS.md, a README file, and it's just doing some stuff here. And then we have our backticks here. We call it threat model, threats, whatever we want to call it. We have some dummy, we have our language. We haven't defined it yet, but I'm just giving this an example. It's going to understand. Now, again, the README is not going to understand it, but somebody's going to go off and say, oh, I understand this specific language is open, and I'm going to go ahead and create some back-end thing that GitHub's going to support, and it's going to render it accordingly. So if we save it as threats.md, we then get this automatic thing that comes up. Again, all the machinery is back in GitHub called threat models or threats and mitigations. And when we click on that, we can go as far as, remember those methodologies and those characters at the beginning of our presentation? We can have it represented as stride. Somebody can write the stride version, and it's writing on top of our specific DSL or pasta, and they can click on it and get the language. Extremely powerful. And this is what we're saying for the potential behind all of this. So finally, we have to feed the threat model to keep it alive. So I've been talking about languages up to this point, but what I haven't been really talking about is how do we keep it alive? Well, we need to define this language first, but now we need the tools to determine what's new. What are the things that are, we're going to check, for example, the deltas. What is the data that we're going to extract from all this information? And John's going to take over here. He's going to do a DFFML demo and describe exactly what this scenario is for us. John?
All right. So let me bring up this. All right, so here's what we're going to be doing. I'll show you all, what we're going to be doing, and then we'll do it, and then we'll talk about it again. John and I talked about the threats.md file and the threat model, the threat dragon threat model, right? And this idea of this open architecture based off of a general purpose description like JSON, right? Or YAML or whatever, right? The point is we have this structure, and we're going to have a schema involved, right? So we're going to be doing a little demo here where, so when I said I'm excited to try this on human and AI agents, we have a project which is spun out of the DFFML project to build sort of this AI software developer. Her name is Alice. And so Alice is going to be helping us generate our threats.md file today. So what we're going to do is, first thing we're going to do is generate just the threat model, and it's just going to have the threat dragon threat model in it, the diagram there, and then as well as the general this open architecture description of the of the threat model, right? So we're doing a conversion. So let's do it here. All right, so let me remove the file, right? So, oops, okay, so there it is. Okay, never mind. Okay, so if we take a look at the file, and let me go to my browser. So this is the file that gets generated here. All right, so, okay, so I don't have the Mermaid for you today, but what we do have is, and I'll paste this into the body of a GitHub issue. So this is what it looks like, right? So I'm just previewing in a GitHub issue right now in the body of an issue, and so we have our threat model, our diagram from Threat Dragon, and then we have our open architecture spec, right? And so this is actually the open architecture for the tool itself right now. So, and you can see basically you've got effectively we have this directed graph of data, and it's a little verbose right now where it's in progress, but the main point is you have your sort of definitions of your data types and your assets, which correspond to the elements that we'd see up here, and then we have our connections between them, right? And so that's getting into how do we link these things together. Okay, so then in the future, we'll have also the Mermaid diagram, which will be synthesized from there, right? But in general, the concept is, okay, you take your source of truth material, right? So in this case, it's your threat dragon threat model, any maybe supplementary data you may have, right, that's written text, and then we're going to combine it all together using Alice and dump it into this THREATS.md, right? And when we do that, this helps ensure that our threat model or our THREATS.md file is always up to date, right? Because we generate that with our CI and we pull from, you know, whatever authoritative sources of truth we have, right? So then let's see. Oh, I had a checklist of things I was supposed to talk about, and I was not doing that. So where is my manifest? Oh, where's the manifest? I can't get to that tab. Oh, here it is. All right. So what is this open architecture? Well, at a high level, and so we also have also been referring to Alice as the open architecture. So she's an entity which is based off of this off of the architecture itself at a high level, and so we use the same terminology to refer to both. So with the open architecture, effectively what we have is like you can think of it almost like a reverse proxy for domain-specific formats of architecture or representations of architecture. And since domain-specific representation of architecture is such a mouthful, we basically have been referring to that as what is effectively a manifest. And so when we talked about earlier, you know, what are these properties of a manifest that allow us to interoperate, right? Well, we looked at the world and we said, okay, so what are some successful formats? What do they do? And how would we, you know, if we treat the world of data as like streams of data, and we may not see file names, we may just see these blobs coming through. What are the things that we need to see in these blobs of data to know what they are, right? To know what an individual element within an architecture is, so that we can appropriately apply threats and mitigations and the auditing, which John showed, in this cross-language way, right? So we figure out what is the domain-specific representation of argument of architecture, aka the manifest, for our source of truth, right? And that source of truth, you know, that we could have multiple sources of truth for different parts of our application, and we're forming them together, right? We're bringing it all together to do this open architecture representation. And so the nodes in that graph are effectively a manifest, and then the top level node of the graph itself is also effectively a manifest, right? Because the same, it's you know, you can represent any domain specific format within this is the goal, right? So, and we need this to be a community effort to figure that out, right? So what are some of the things that are involved in a manifest, right? Well, we looked around and we said, JSON schema did a lot of good, you know, they learned some, they have built a lot for the community, right? We stand on the shoulders of giants. And so we know that documents should have schemas, because a schema will allow us to understand, well, what is this thing? When I hit a new node in the graph, it'll let us say, okay, well, what should I expect this node to contain? And if I know what I can expect the node to contain, right, I can do my input validation. And then when my tool consumes from the graph, then it you know, I can have a tool that understands the various different formats and the schemas that are applicable to each format. And then basically there's this concept of sort of the shim that says, all right, well, given this format for this domain specific representation of architecture, let's jump into this auditor, right? Or this visualization, right? And then we output that all to the THREATS.md, and that way it stays alive, right? It's not stale. It's always coming from the source of truth. So, so effectively, the main thing that there was 3 properties, which we said, these are good things, the manifest metadata, right? Which a manifest should have, which would allow us to effectively validate any blob of data, right? And say, we understand this thing as if it's part of the open architecture. It's part of this proxy format, right? And that is the format name, the format version, and the schema for that, right? And so we can combine all those things with little little shorthand, we'll put them all in the URL, right? And basically the file name gives us all three of those. And then when we resolve the URL, we get the schema, right? And so if we have this information, then we can write our parsers off of it, right? Or our auditors, right? And then so we talked a little bit about the concept of overlays. So the default flow that we just ran, right, to generate the, okay, I've got a lot of stuff on my screen here. Can you all see the top bar? You can't see the top bar, right? All right, I'm gonna assume you can't. You know what, I'll hit enter a few times in case you can. So this command, which we just ran, right, to generate the threat model, this just you know, source of truth in, and then good threats out. But what we would like to do is run that auditor that John showed, right? So, and here's the auditor again, right? And so we want to run this as along with generation of the threat of the threats.md, since we're thinking CI/CD, we want to make sure that this source, that threat model conforms to like the code that we're seeing, right? Or in this case, you know, we just want to check just a few basic checks on the threat model itself to make sure it's complete, right? And so we can start to combine this by adding overlays. So what we did here is we basically just, we made a little overlay. All it is with the underlying framework that we're using, DFFML, basically all of this is typed, right? Because if you think about these manifests in the schema, you got to have some types. So we're going to go ahead and just throw a little type hinting on there, and then create this overlay, which is basically saying, all right, we have this audit operation, right? And so what we're going to do is we're going to export the audit operation to this open architecture format, right? So, oops, once again, I can't really see here, but I'm hoping that you can. All right, so we export the open architecture to this format, and then what we're going to do is run the same generation with the overlay, right? So now what it's going to do is it's going to check for it's going to run that auditor internally, right? Along with, let me make sure we're running the overlay. Right, so it's going to run the auditor there, and we should see, you know, oops, wait, where are we? It's the wrong command. The command is running over here. All right, we're going to run it over here. All right, so this is the same command, different terminal with the right context, and we end up, you know, with, once again, the threat model. Oh, wait, wrong file. So model, good threats, right? So here's the file again, right? And this time we've run through the auditor before we generated it, right? And that way, if the auditor failed, it wouldn't spit out good threats.md, and we'd fail the CI job. All right. Let's see. And then let's see. So there's a few things that we want to, you know, we'd like to ask the community to help us with, right? And we'd like everybody to, you know, think about this concept of the open architecture and how you might build tools around this, and then also collaborate with us and comment into the thread, which we'll link here. And we're going to have this as a pull request soon. Right now, it's just a discussion thread on GitHub. So we'd like people's feedback and to play with the tools that we showed, you know, with the auditor and with Alice, and try to figure out, you know, how is this stuff working for you? You know, are you having success with it? Are you seeing places where we could extend? Do we need to modify the concept of what metadata is required, right, for us to be interoperable? Is there some more pieces of information that would be required beyond the schema, the format name, and the version, right? And then we're also looking to, you know, create this as along with commenting on the thread, we're looking to make this into a working group, right? And so within that working group, we'll try to figure out how does this all you know, that can be our forum for discussion. There was some adjacent work. I think maybe I saw in the mailing list the other day, the SPDX abstract syntax tree stuff. Sounds like, look, from what I saw, it might be vaguely related, but we need to pull in everybody who might be working on this type of thing, and you know, think together about how this works. And some future stuff that we wanted to do is combine scan data, right? So your static analysis data to understand, are all these the components that are really in your application, right? So using something like CVE Ben tool, we could augment, right? We output to the open architecture from CVE Ben tool, and then we augment the auditor to ensure that if you saw a database in your scan results, that it better show up in your threat model, right? So yeah, I'll turn it back over to John, but just a call for engagement here.
Awesome. Thank you, John. So wrapping up here, there was a question. We did an interview with Adam Shostak. Like, it was like one of the most exciting OWASP podcasts we did a while back. And I think it was like 2018. That's how long ago it was. But there was a question in there about, can we fully automate threat modeling? Could we just take the humans out of it? And he responded back with a question, and he said, can you fully automate programming? And then I said, I don't think so, not now. But here's something to think about. I just did a look. Yeah, I did a Google. There's 128 million repos on GitHub right now. And we know every one of them are quality repos with threat models. No, just joking. But if you took 10% of that or something less, and let's just pretend people decide to threat model, and let's pretend that people are making it publicly available, right? I think some teams are, but we just never see it. But let's say they're using this 20 years from now, 10 years from now, it's optimistic. Then you have this huge corpus of data that you can then start creating your machine learning models from there. And I think then that's the big picture, that maybe then not only that you have these commits where GitHub is already looking for things, but you could also have a threat model check, and it could come back and give you a pretty good, risk score, or whatever you want to call it, from that. So there's a lot more involved here. Again, if we're all speaking the same language, and that language, of course, is this language, and the tools that, and again, the people are going to build the tools accordingly. So yeah, we do appreciate it. If there's any questions, please feel free. As John said, we're looking for input, and we're going to keep moving forward with this. And something's got to happen. Something has to happen to make these more secure. So we appreciate your time. Thank you.
Thank you.
Thank you again, gentlemen. Thank you, John and John. We really appreciated that talk. I'm actually looking forward to potentially grabbing the slide deck from you if that's possible. And I'm going to put the sponsor. Are there any questions before we switch over? Let me take a look at the chat. Have we taken all the questions? Yeah, it looks like it. If there are any final questions, we have a couple of minutes. Please let us know. Otherwise, I'd like to once again thank our sponsors: GitHub, CINAC, VLST Security, Security Innovation, Forward Security, WebSec, Plurilock, NetSpy, and Cycode.